Hello friends, welcome back to the class of fluid mechanics. Till now we have seen what is fluid mechanics, what are different types of fluids, what are different properties of fluids like density, specific gravity, specific weight, viscosity, surface tension. Okay? Now, in today's session we will see about one more important property of the fluid which is known as capillarity. Now, what is the capillarity? In the real life, you have seen the example of capillarity. This phenomena, you have gone through this phenomena in the real life. When you drink the cold drink with the help of some straw, you used to go to the hotels, order the cold drink, and you enjoy with the help of some straw. What happens? When you dip the straw inside the cold drink, the level of the cold drink rises in the straw. Okay? This is the example of capillarity. Now, why it is happening? Have you observed why this phenomenon occurs? See, if you observe the straw carefully about its dimensions, its length is very much big as compared to its diameter. The length of straw is bigger as compared to the diameter of the straw, okay? Because of which there is effect of capillarity. And the liquid, whatever liquid it is cold drink, it rises up. So this is the capillarity. Now we will see some important points about the capillarity. Capillarity effect. What is the capillarity effect? Let us taking the example. We are taking a tank filled with water. Okay. Now what is happening? These two vertical lines. These are nothing but walls of the straw or tube. You can say. You have inserted some tube of very large length but small diameter. So when you dip it inside the water, what will happen? The level of water will rise upside. You can see the level of water in the tube is greater than the level of water in the container. This is due to the capillarity effect. And this curved surface, this is nothing but, this is known as meniscus. This curved surface is nothing but, it is called as meniscus. Now second case, we are taking another container in which we are taking mercury. And in this also you are inserting same tube or straw. What is happening? The level of mercury is going down inside the tube. So in case of water, the level of water is rising up in the tube. In the case of mercury, the level of mercury is going down, falling down inside the tube. Now why it is happening? And this h represents the height. This h represents the height, difference of height in the container and in the tube. Okay. Now why it is happening? For different type of liquid, different type of cases are happening. Why? What is the reason? Anyone can tell? Okay, I am going to tell you the reason. See, first of all, what is capillarity? Capillary effect is nothing but it is a rise or fall of liquid in a small diameter tube. This is a small diameter tube. In one case it is rising up, another case it is falling down. Okay, this is the capillarity effect. Now, the curved free surface, this curved surface, this is known as meniscus. Why it is free surface? Because above this there is nothing, there is air. Okay, so it is known as free surface. It is curved. This curved free surface is known as meniscus. In both cases, it is called as meniscus only. In one case, it is rising, so it is U shape. Another case, it is falling, so it is inverted U shape. Now, in case of water, why meniscus is going up? Because the water is known as wetting fluid. What you understand by wet? Wet means gila. Okay, so the nature of water is it wets the surface, the wall of these tubes. It the water will wet the wall of these tubes. Okay, that's why meniscus is going high. But mercury, the nature of mercury is it is non-wetting fluid. Non-wetting fluid means it will not wet your surface of the or walls of the this tube. Okay, that's why the surface or the meniscus is falling down in the mercury. Something is written here. It is non-wetting fluid. Okay, so the meniscus is going down. Now you need to find the value of H. How you will find? By doing force balance. What are the forces acting here? And you will balance, you will get the value of H. So this you can refer in the books or also in the net also. How to find the value of H. Okay. Now one more important property, or you can say two more important property. They are correlated to each other. One is compressibility, another is bulk modulus. Compressibility. What is compressibility? From the word itself, compress. Something you are compressing. When you are compressing something, what happens? When you take a balloon filled with air or gas, you compress it. Means what you do? When you compress, the pressure will increase and the volume will decrease. From there, this property came compressibility. Now we will see about it. We are taking this cylinder piston arrangement. This is cylinder, this is piston, and this you have insulated. So there will be no loss of any energy. Now, at this end of piston, you are applying pressure P. The original volume of the cylinder is V. When you apply this force on the piston, this piston will try to move on the left side. This piston will move on the left side. Okay? Let it moves by volume del V. Let it moves by volume del V. Now the volume will decrease. The volume of cylinder will decrease. It will become V minus del V. V minus del V. And pressure will increase. I told you in the compressibility what happens? The volume decreases, the pressure increases. So let the increase in the pressure is del P. Decrease in volume is del V. Increase in pressure is del P. Okay? Now, same thing is here. V is the original volume of the cylinder. P is the pressure acting on the gas on the volume V. Now pressure is increasing by P plus del P and volume is decreasing by V minus del V. Okay. So what is the total increase? Total increase is del P. Total decrease in the volume is del V. Okay. Now what do you understand by strain? Change in dimension. What is strain? Change in dimension by its original dimension. Now here dimension is volume. So volumetric strain is nothing but change in volume divided by original volume. Okay. Now change in volume because it is decreasing, volume is decreasing. So it is minus dV. Because volume is decreasing, it is minus dV. So the bulk modulus will become how much? Bulk modulus is represented by K. It is given by increase of pressure divided by volumetric strain. Increase of pressure divided by volumetric strain. Unit will be Newton per meter square. Unit of bulk modulus will be Newton per meter square. Why? Because strain it is dimensionless. Volume divided by volume. So it will cancel out. Okay. And unit of pressure is Newton per meter square or Pascal. So Newton per meter square is the unit of bulk modulus also. Now it is given by increase of pressure divided by volumetric strain. What is increase of pressure? dP. What is volumetric strain? Here it is given minus dV by V. Put it, simplify, you will get minus dP by dV into V. This is nothing but bulk modulus. Now, what is compressibility? Mathematical expression of compressibility is nothing but it is inverse of bulk modulus. Compressibility is inverse of bulk modulus. So it is given by 1 by K. 1 by K. Okay friends. So you have seen about capillarity effect, about compressibility and bulk modulus. So today we have deal the three properties of the liquid. I hope it is clear to everyone. So it's over for today. Thank you everyone for having listening my lecture with the patience. We will meet you in the next session. Till then, goodbye. Take care.